Hello, and welcome to the AstroGuy Podcast. I'm your host, Wayne Zuhl, and I want to wish all of you a very happy new year. January is here, and with it comes cold winter weather and some of the best stargazing nights of the entire year. Long nights, lower humidity, and crisp, transparent air combine to deliver skies that are often steadier and clearer than at any other time. While you may need an extra layer or two to stay comfortable, the reward is darker skies, sharper views, and constellations that seem to sparkle with extra intensity. For observers of every experience level, January offers a front row seat to some of the most spectacular sights the night sky has to offer. In this episode, we'll explore the planets, catch up on astronomy news, explore an ancient lunar crater, and then explore some of the best sights that Orion the Hunter has to offer on January evenings. But that's enough of my rambling. Let's start with this month's Planetary Roundup. Spotting Mercury will be difficult this month, as it only makes a brief appearance as the year begins. It may be briefly visible for a few mornings, glowing at magnitude minus 0.6, very low on the eastern horizon, about 30 minutes before sunrise. Venus and Mars both appear too close to the Sun to be spotted this month. Both will reappear in early spring, with Mars showing up in the morning sky, and Venus becoming visible in the evening sky. Jupiter dominates the evening skies this month, rising in the east after sunset and shining brilliantly through the night. On the 1st, it rises at 5:19 p.m. and transits the meridian around 12:45 a.m., shining brightly at magnitude minus 2.67 in Gemini. By the end of the month, Jupiter rises just after 3 p.m., and it's transiting the meridian around 10:30 p.m., fading slightly to magnitude minus 2.62. Jupiter reaches opposition on January 10th, placing it opposite the Sun in our sky and making it visible all night long. This is the best time of the year to observe the planet. On the evening of January 3rd, around 8 p.m., the nearly full moon will appear about 3 degrees to the left of Jupiter, creating a beautiful pairing, visible to the naked eye and in binoculars. A similar scene occurs on the evening of the 30th, when the 95% illuminated waxing gibbous moon will sit about 4 degrees north of Jupiter. Saturn begins the month transiting the meridian around 5 p.m. before sunset, shining at magnitude 1. It's visible in the early evening low in the southwestern sky in Aquarius, setting just before midnight. By the end of January, Saturn transits around 3:11 p.m. and sets shortly after 9 p.m., so now's the time to catch it before it disappears into the twilight glow as winter continues. Uranus remains visible in Taurus all month long. At magnitude 5.7, it sits right at the edge of naked eye visibility under dark skies. But even under light-polluted skies, it's an easy binocular object and looks best in a telescope. This month, it's conveniently located about 5 degrees south of the Pleiades, making it much easier to track down. Neptune stays near Saturn throughout January, but at magnitude 7.8, you'll need a telescope and an accurate star chart to spot it. Be sure to observe it soon. Later this winter, it will slip into the twilight, and you'll need to wait until later in the year to catch it again in the morning sky. Finally, the quadrantid meteor shower peaks from January 2nd into the 3rd, but unfortunately the full moon will wash out all but the brightest meteors. Sadly, 2026 is not a good year for the quadrantids. As I record this episode, there are no comets brighter than magnitude 9.5 that are visible. Comet 3I Atlas made its closest approach to Earth in December, and surprise, nothing happened. Now let's move on to some quick astronomy news. SpaceX is planning to launch Flight 12 of the Starship sometime in January. In 2025, there were 5 flights of Starship. Expect that number to increase this year. The big news is Artemis 2, which will be the first mission to bring humans into lunar orbit in more than 50 years. It is scheduled to launch on Thursday evening, February 5th. Now, it is possible that that date will change. The 10-day flight will see 3 Americans and a Canadian astronaut orbit the moon for several days, checking out Artemis's systems, in preparation for Artemis 3, which will see humans return to the surface of the moon for the first time since Apollo 17 in 1972. We'll have more on this next month. Now it's time for the
Lunar Feature of the Month.
This month, we're highlighting one of the most intriguing ancient impact craters on the moon's near side. Named after the famed Greek astronomer Hipparchus, often considered the father of trigonometry and one of the earliest scientific star catalogers, this crater lies just southeast of Sinus Medii, near the center of the lunar disk as seen from Earth. At roughly 93 miles or 150 kilometers across and about 2 miles or 3.3 kilometers deep, Hipparchus is enormous, but unlike younger craters with sharp rims and dramatic central peaks, Hipparchus has been heavily worn and eroded by billions of years of impacts. Its western rim has been almost completely obliterated, leaving behind only low hills and subtle rises, while the eastern wall still retains some recognizable structure. The crater floor tells a fascinating story of the moon's ancient past. Portions were flooded by basaltic lava long after the original impact, smoothing out large areas, while the southwestern section remains higher, rougher, and more rugged. Any original central peak has long since collapsed and eroded, leaving only faint rises and the partial rim of a flooded inner crater as clues to its former structure. Hipparchus also hosts several smaller craters within its boundaries, including Horrocks, which sits entirely inside the northeastern rim. Along its edges, Hipparchus is closely associated with other massive formations, most notably Albategnius to the south and Ptolemaeus to the north, creating a complex and overlapping region that illustrates the moon's long history of impacts. Because of its broad degraded walls and subtle terrain, Hipparchus really comes alive around the first and last quarter phases, when low-angle sunlight casts long shadows across the crater floor. Through a telescope, these shadows help reveal gentle slopes, ghost craters, and low ridges that might otherwise go unnoticed, making Hipparchus a rewarding target for patient lunar observers. I hope that you'll explore this crater the next time that you're observing the moon. Now it's time to head out of the solar system and explore what many consider the greatest winter constellation in the night sky, Orion the Hunter. Dominating January evenings, Orion is easy to recognize and impossible to ignore, with its distinctive belt and some of the brightest stars that we're able to see. The constellation sits right on the celestial equator, making it a favorite for observers in both hemispheres. Orion is also a showcase for stellar evolution, from massive blue supergiants to active star-forming regions, and it hosts some of the most famous deep sky objects in the entire night sky. Whether you're observing with the naked eye, binoculars, or a telescope, Orion never disappoints. Let's start our tour with Rigel, known as Beta Orionis, the brilliant blue-white star marking Orion's foot. Shining at magnitude 0.1, Rigel is the seventh brightest star in the night sky, and is located about 850 light-years away. Despite its great distance, it shines brightly because it is a massive blue supergiant that radiates tens of thousands of times more energy than our Sun. It is estimated to be about 70 times the size of the Sun, and could be as much as 24 times as massive. Rigel is also an excellent example of just how extreme massive stars can be. With a surface temperature exceeding 12,000 degrees Kelvin, its intense blue-white color is a clear indicator of its youth and mass. Stars like Rigel live fast and burn through their fuel quickly, and while it may look calm and steady to us, it's racing toward a dramatic future. Astronomically speaking, Rigel is nearing the end of its life and is destined to explode as a supernova, enriching its surrounding region of space with heavy elements. Rigel is stunning to the naked eye and makes a great color contrast with the reddish glow of nearby Betelgeuse. Under steady seeing, a small telescope can reveal Rigel's faint companion star that shines at magnitude 6.6 and sits about 9 arcseconds from the primary star. It provides a rewarding challenge for patient observers. Now let's move to Betelgeuse, or Alpha Orionis, the unmistakable reddish-orange star marking Orion's shoulder. Betelgeuse is a true red supergiant, a massive star that has reached the final stages of its life, and one of the largest stars that's visible to the naked eye. Unlike most stars, its brightness isn't constant. Betelgeuse is a variable star, changing in brightness over months and years as its outer layers expand and contract. It is listed at magnitude 0.5, but can be as bright as magnitude 0 and as faint as magnitude 1.5. Located roughly 500 light-years away, Betelgeuse is almost beyond comprehension in size. If it were placed at the center of our solar system, its swollen outer atmosphere would extend beyond the orbits of Mercury, Venus, Earth, and possibly even Mars. Despite its enormous size, the star is relatively cool by stellar standards, giving it that distinctive warm orange-red color. Betelgeuse has also attracted a great deal of attention in recent years, especially after its dramatic dimming event in late 2019 and early 2020. While it's not about to explode anytime soon, astronomers know that Betelgeuse will eventually end its life in a spectacular supernova, one that would be visible even in daylight, though that event could still be thousands of years away. Betelgeuse's color is easy to see with the naked eye, especially compared with the blue-white glow of Rigel. Binoculars enhance its deep orange hue and make its subtle brightness variations easier to appreciate over time. If you're looking at it in a telescope, defocus the star a bit and you'll really be able to see its color. Our first deep sky object on our tour is the true showpiece of Orion and arguably the crown jewel of the winter night sky, the Great Orion Nebula, M42. Even to the naked eye, M42 appears as a soft, misty glow as the middle star in Orion's sword. But what you're really seeing is a vast, stellar nursery located about 1,300 light-years away, where new stars are actively forming out of enormous clouds of gas and dust. This nebula glows at magnitude 4 and spans more than 1 degree square. M42 is about 13 light-years across. Through binoculars, M42 shows its familiar wing-like shape, while a telescope reveals intricate structure, glowing arcs of gas, dark dust lanes, and subtle variations in brightness that seem to change with magnification. At the heart of the nebula lies the Trapezium cluster, a tight grouping of young massive stars whose intense radiation causes much of the surrounding gas to glow. Just north of M42 is its smaller companion, M43, sometimes called Demarion's Nebula, named for Demarion, who first discovered it in 1731 before Messier catalogued it in 1769. Although it's part of the same vast nebular complex, M43 is separated by M42 by a prominent dark dust lane, making it appear as a distinct object. M43 surrounds a bright young star that illuminates the nearby hydrogen gas, creating a rounded fan-shaped glow that contrasts nicely with the broader sweep of M42. From my backyard, the complex is visible to the naked eye as a misty glow, marking the center of Orion's sword. In my 70mm refractor, it is a joy to observe, but the best views usually come through my 8-inch Dobsonian at low power, where the nebula really begins to show its structure. This region responds well to a nebula filter, which can make a noticeable difference, especially if you're observing from a very light polluted location. M42 and M43 are the kind of objects you can easily get lost in for hours, and they're the ones that you'll find yourself coming back to again and again. Our next object is not as bright or well known, but still an interesting object in its own right. I'm referring to Messier 78, which is sometimes called the Casper the Friendly Ghost Nebula. This is one of the brightest reflection nebulae in the night sky. It's located about 1,350 light-years away and spans 8 by 6 arc minutes while glowing at magnitude 8.3. Unlike M42, which shines because its gas is energized by hot young stars, M78 glows by reflecting starlight off surrounding dust, giving it a soft, grayish-blue appearance under dark skies. M78 surrounds 2 young stars that illuminate the nearby dust clouds, and while it lacks the dramatic structure of the Orion Nebula, it has a delicate, ghostly beauty of its own. This region is still actively forming stars, with dark nebulae and hidden protostars embedded within the cloud. M78 is best observed with a telescope under dark, moonless skies. In binoculars, it appears as a small, faint, hazy patch, while a telescope at low to moderate magnification reveals its irregular shape and the pair of embedded stars. A nebula filter generally won't help here. Dark, moonless skies are the key. To find M78, start at Mintaka, the westernmost star in Orion's belt, and sweep 3.5 degrees east, and you should spot it. The last object on this month's tour is a fun and often overlooked object, NGC 2169, a small open star cluster near Orion's Rays Club. It was cataloged by William Herschel on October 15, 1784. It is often nicknamed the 37 cluster because its brightest stars form the numbers 3 and 7. This cluster is a fun and easy target that offers a nice contrast to Orion's nebulae. Located roughly 3,600 light-years away, NGC 2169 is a relatively young cluster, and its stars are loosely grouped rather than tightly packed. The cluster is bright at magnitude 5.9, and it spans about 7 arc minutes across. NGC 2169 looks best at low magnification and is an excellent target for binoculars or small telescope. Once you see the 37 pattern, you'll never forget it, and it's a fun object to share with newer observers. In my 70mm refractor, the 37 pattern is immediately obvious. Finding this cluster is easy as well. Just imagine a line from Betelgeuse to Tejas. NGC 2169 lies about half a degree east of the midpoint of that line. Once you find it, you'll have no trouble spotting it again. And that wraps up this month's tour. I hope that you found it enjoyable and that it inspires you to step outside on a clear night, look up, and spend some time under the stars. Thank you for joining us. If you've got questions, feedback, or ideas for future episodes, I'd love to hear from you. You can email me at AstroGuyPodcast@gmail.com or send a text or a voicemail to 973-404-0380. Be sure to check out the AstroGuy Podcast group on Facebook and visit our YouTube channel for past episodes, observing tips, and bonus content. If you've enjoyed this episode, please like, subscribe, comment, and share. It really helps us reach more fellow skywatchers. If you'd like to buy us a cup of coffee, we'd appreciate it, as all the money goes to producing these episodes. I'll leave a link in the show notes if you'd like to donate. Until next time, may your skies be clear, and as always, Carpe Noctem, seize the night. I'm Wayne Zuhl, and this was the AstroGuy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.